I'm going to remind you of a couple things that we talked about on Thursday. If you didn't get these notes down, make sure you get these notes down. Slope can be positive or it can be negative. And when we find slope, we're finding rise over run. And mathematically, if we're looking at a table, we're looking for delta y over delta x. And that delta just means change in. It's the Greek letter delta. It's a symbol of a little triangle. Let's focus our attention on this for right now. When we're walking a slope, remember, we always want to be walking from left to right. So I'm going to draw myself a little stick figure person here who's walking with a little arrow that shows them going up and to the right. When you look at a slope, I want you to imagine a little person walking along it, but they always walk from left to right. The same direction that we read a book in English. Right? Some languages don't read from left to right, but in English we do. So let's do this. Before we get into deeply on the slope values, I'm counting our slope triangles and such for problem 25. Could I get you to go through these lines in problem 25 and just label which ones are going to have a positive slope and which ones are going to have a negative slope? For example, I know that A is going to have a positive slope because if I imagine a little guy walking on this from left to right, he's going to be going uphill. That's a positive slope. So I'm going to put a plus next to that line. Can you just label for me on the other slopes on this problem, which ones are going to be positive and which ones are going to be negative? So put some pluses and minuses next to those. Got it already? All right, you're quick. You know what? I'm only seeing one that's negative. Are you only seeing one that's negative also? What's the one that's negative? D would be negative. If you were moving from left to right along D, you'd be going downhill. So B and C would both be positive slopes. So this is the number one mistake that people make when they're dealing with slopes. In fact, in this whole chapter, this will be the most common mistake. This will be the number one thing that will lose people points on our chapter 2 test. People are going to look at a line and they're going to forget to check whether it's positive or negative. Okay, it's really easy to mess up. But the shortcut to it is just put your finger along it. Move your finger from left to right. If you're going uphill, it's positive. If you're going downhill, it's negative. All right, other than that, it's just a matter of counting your slope triangles out and getting them into the correct order. So if I'm counting a slope triangle, and I got lots to choose from here, but I'm going to pick the smallest one that I can. And for line A here, it looks like I'm going over 1 and up 1. So they're both the same. So my slope would be 1 over 1. And we'll simplify that. What is 1 over 1? 1 over 1 is 1. So the slope for line A would be 1. And it's a positive one because we said it was positive. For line B, it looks like we're going over 1 and up and down 3. Now this one's a little tricky because we got to make sure that we get the right thing on the top and the right thing on the bottom. This is another easy way to make a mistake. Remember from our notes, we want rise over run, or y, change in y over change in x. So the one of these numbers that's in the y direction is definitely the 3. 3 is going up and down. That's our rise. and our run is 1. So 3/1, it's positive 3/1. 3 divided by 1 is just 3. So we would say the slope of that line is 3. All right, looking at C, we can pick any of these triangles that we want to. I don't know why I'm choosing that one. Put our numbers in, count our slope triangles. Looks like we got a 2 and a 1 this time around. And again, just make sure you remember that it's positive and then get that correct number in the right place in your fraction. We want rise over run. So this one will be 1/2. And 1/2 is the same as 2, right? Right? No? 1/2 the same as 2? No, it is not. It is 1/2. So we have to leave it like that. We can't do anything with it. That doesn't simplify. All right, last one here. This one we were going. We got to remember it's a negative slope, so we've already written that down. That's good. And if I count, it looks like I've got a 2 here and a 5 here. So negative, which one would go on the top? Rise over run. So 2/5. So negative 2/5 for that slope. That doesn't reduce at all. All right, so I would like you to practice doing this in number 26 for me. Now, number 26 did not draw the triangles for you. So you need to practice drawing the triangles, but don't forget about positive versus negative. In fact, I would recommend before you do anything else that you go through all those lines and you determine which lines are going to be positive slopes, which lines are going to be negative slopes. Why don't we do that first? So next to each of these letters, A, B, C, D, and E, let's write pluses or minuses. A positive or a negative slope? If I walk from left to right, I would be walking uphill. That's positive. What about B? Positive or negative? B is positive. What about C? Positive or negative? C is this one right here. That's positive. What about D? D is negative. We're going downhill with D. And then E is kind of a weird one. It's flat. So if I'm walking on a flat surface, I'm not going uphill, so it's not positive. And I'm not going downhill, so it's not negative. What is the only number that is not positive or negative? 0. So E has a slope of 0, and that one's done. We don't need to do any work for that. If you ever see a horizontal line, its slope is 0. We don't need to worry about making a triangle and doing rise over run for E. We're already finished. It's 0. But for all the rest of them, we do need to make a slope triangle. You can choose any 2 points on that line that you want to make your slope triangle. For A, I don't know why, but I'm choosing those 2. And I put my numbers in there, and then I write my slope. Could you guys go ahead and find slopes for me for B and C and D and A? Make sure you're drawing those slope triangles. Sketch those slope triangles in while you're doing this. Draw those triangles and then write the numbers in next to them too. The rise up down. All right, let's see how we did here. For line, let's see, let me do line B first. So line B, I'm picking this triangle here. And it really shouldn't matter what triangle you pick. We should get the same answers. Line B, that's a positive slope. Rise over run, so I want 3 over 2. So positive 3 over 2 for line B. Is that what you got for line B? Woo! All right, line C. Let's find a good one for line C. I'm gonna go this one down here. And it doesn't matter if your triangles are above the line or below the line, as long as they follow the grids and they go from one point to another. Ooh, this is the same thing but backwards, right? So this one's going to be, sorry, 2 over 3, and it's also positive. Interesting. And then line D, that's our negative slope. I did this skinny long triangle here. Its rise was 1, its run was 1, 2, 3, 4, 5. So it was negative 1 over 5. Make sure you include that negative. Did you put that negative in your answer for D? Yeah. Was it in front of your fraction? Good. Any questions on 26? 26, any questions? All right, 27 is in your book, and it is on page, let me get your page number here, page 55. So if you could please open up your book to page 55. Yes. Are they all out? I'll leave mine up. Is there one there? There's one over there. I'll leave mine up on the screen. Can you see it? Can you read it okay from where you're at? If you don't have a book, that's all right. I'll leave mine up on the screen here. And then when we get to homework here in a minute, you can just share with someone else. All right, so your task right now is number 27. It's got parts A, B, C, and D. So conveniently, that matches up with parts A, B, C, and D here. And they're going to ask you to graph a line to match. Okay, should we do one of these together?
Yeah.
No, yeah, okay, let's do one together. We'll do part A together. So I can't put both of these on the screen at the same time, so let's go ahead and write the important information. For part A, they told us they wanted to match the equation y equals 3 over 5x minus 1. 3 over 5x minus 1. What is the slope of this line going to be? What is the slope of this line going to be? 3 over 5. That's the slope. That number in front of the x is the slope. So the slope is 3 over 5. Is that a positive slope or a negative slope? Positive slope. So we should be marching uphill. And when we make our slope triangle, where's the 3 going to go and where's the 5 going to go? Is the 3 going to go up and down or is it going to go left and right? Up and down, right? It's rise over run. So the 3 is going to go up and down and the 5 is going to go left and right. Now, where are we going to start this graph along our y-axis? What is our start value? -1 is our start value, so we're going to start it at -1. We always start on the y-axis at the y-intercept. And from that point, we're going to make a slope triangle that looks like this. It's going to go over 5 and up 3, or up 3 and over 5, however you want to go. I'm going to go up 3 and over. Ooh, hang on. Oh, they got tricky on us. I just realized something. Erase. I just looked at the scale on this. Did you see the scale? Do you see what they're trying to do to us here? Oh man. It's not any how bummer. That's all right. Sorry. We can deal. Take a deep breath, height. It's gonna be all right. Take a deep breath. It's gonna be fine. I just noticed where the 5 is. You see where the 5 is? The 5 is not on 5 tick marks. It's like 2.5 tick marks. So how big is each tick mark? Each tick mark is 2. Half the tick mark is 1, right? So let's back this up. Let's make our y-intercept at -1, which would be here, halfway in between. And then this is going to be kind of tough. But we're going to have to count up 3 half tick marks and over 5 half tick marks. So 1, 2, 3. 1, 2, 3, 4, 5 is going to get me to there. Oh, I do not like this. You know what? Me personally, if I had graph paper, I would do this on regular graph paper. Does anybody have their own graph paper? If you want to, you're welcome to do this on your own graph paper. All right, so that gets me a couple points here, and then we can just connect those and carry it on, and that makes ourselves a nice line. There's our first one. All right, so the next 3 are up to you. Use the clues that they give you in the problem to create a line. And draw that line. So use the clues that they gave you. Feel free to talk it over with the neighbor. Feel free to spy on a neighbor's work. Feel free to check in with a neighbor and see what they're doing. You want one? Sit right over here. Grab one. They don't give you a starting wherever you want to. Any place on that thing. Right. And then so the change in y was what? -6. That's when they're cut down 6. Yeah, sure. Actually, you could do either one of them. But yeah, just put a little one. All right, and then +4. Which way was positive? Left or right? Right. Yep. What about this one? Which one are you doing? Oh, you did this one. Yeah. Just cross up that. How are we doing? And then it's a change. I heard you say this. All right, I got questions. I'm coming around. We're gonna go over these, of course, but yeah, so normally we expect to see a number out in front of there. The number can be always put in front of that. Yep. And you have to turn that into a fraction. There. So now you got to slope 1/1. Well, you just need to draw a line. So essentially where to start, you can start anywhere you want. You draw me a point here. And then it says you change x, or is that left or right? X is left and right. Positive or right. Changing y is -6. That number down. Negative is down. You just created your time. Yeah, well, just make it a little bit. So then it's a triangle and then just connect it. All right, let's talk through these. Part B was kind of weird. They told us in part B was that our change in x was 4 and our change in y was -6. They did not give us a starting location, right? In part A, they gave us the starting location as part of the equation, but they did not tell us where to start here. So everybody's graph might be a little bit different in part B, and that's okay. So you can start wherever you want. So just pick some random points on your graph and start there. I'm starting right here, but if you started someplace else, that's fine. And then you're going to build your slope triangle by looking at these values. So change in x was 4. X is which direction? Is that left and right or is it up and down? X is left and right. And if it's positive, is that to the left or to the right? Positive 4 would be to the right by 4. So I'm going to count over 4. 1, 2, 3, 4. And I'm remembering that each one is like half of a grid line. And then my y, change in y is -6. Y is up and down, but if it's -6, that should be going down by 6. So I'm going to go 1, 2, 3, 4, 5, 6 gets me down to there. And there's my new point. And that creates the two sides for my slope triangle. So we've gone over 4 and down 6. And does that make sense? If I did a slope and put change in y over change in x, it would be -6 over +4, which would simplify to -3 over 2. That is a negative slope that I just drew, isn't it? It's a negative slope. And is it 3 over 2 is the slope? Yes, totally. Totally 3 over 2. Because 6 over 4 would reduce to 3 over 2. Now again, yours might have been in a different spot. Maybe you had a line that looked like this, because you started your point over here. Or maybe you had a line that looked like this because you started your point up here. That doesn't matter, but it should be heading downhill like mine is there. All right, 27, they gave us an equation again here. This one's, so this time we do have a starting value. We've got x minus 7. So we know that our starting value is at -7, so we can find 6, 7 and draw that first point there. But they did not give us a slope, or did they? What's the number that we're always allowed to put in front of a variable? 1. And if I change the 1 into a fraction, what would it look like? 1 over 1. So we do have a slope. Our slope is +1 or +1 over 1. It's positive, which means we're going uphill. And if I drew my slope triangle, it would have a 1 and a 1 on it. So from here, I just need to go up 1 over 1. And then I could keep going up 1 over 1, up 1 over 1. But we should end up seeing a line that looks something like that. All right, and then G, this is the weird one. Change in y is 3, change in x is 0. So again, they didn't give us a start value. So we can start wherever we want. I'm going to start, I don't know, I'm going to start right there. And my change in y is 3. Is that up or down? Y is up and down. Which one is +3? +3 would be up, correct? So I'll count up 3. 1, 2, 3. And then my change in x is 0. So I don't go left or right at all. So we don't really have a triangle here. If I were to connect those dots and continue them, it's going to look something like this. Someone describe that line for me. What's the word that we use for a line that goes straight up and down? It's a vertical line. Now your vertical line might have been in a different place because they didn't tell us where to start. So maybe you had your vertical line over here, or maybe yours was right over the y-axis, or maybe it was over here. But you should have a vertical line for part T. All right, I want to write down a couple more quick notes in our packets here. So we saw a couple of weird cases today. So if a line looks like this, it's a positive slope. If a line looks like this, it's a negative slope. If a line looks like this, it's a horizontal line. What is our slope? We saw one of these today. If it's totally flat, slope is 0. It's not positive, it's not negative, it's 0. If a line is vertical, though, we haven't used this word yet. If a line is vertical, the slope is we say undefined. Undefined. Undefined is what we use in math to sweep things under the rug that we don't want to deal with. Have you ever heard that term, sweep something under the rug? Like if you're cleaning up, why would you sweep something under the rug? You should pick it up and clean it up. You sweep something under the rug if you're just like, you just don't want to deal with it. And in this case, the reason we don't want to deal with this is we've got change in y over change in x, right? If it is a vertical line, how much is your x changing from any 2 points? If I pick a point here and I pick a point here, how much is my x changing? How far am I moving left and right to go from this point to this point? Trick question. I'm not, right? So what number represents not? Would you agree that my change in x is going to be 0 for any 2 points on those? I'm not moving left or right on a vertical line. So the problem is we can't divide by 0. It's mathematically undefined to divide by 0 because it just doesn't make sense. How can you divide something into 0 equal parts? You can't, right? If I have a pizza and I want to divide a pizza into 0 equal parts, it's not possible to do it. Exactly. The only way you could do it is to obliterate the pizza, which means we'd have to obliterate everything, which means everything we know and love would cease to exist. We don't want to do that. So we can't divide by 0, so we have an undefined slope. We can't really do that. We're just going to say that's an undefined. It doesn't mean the line doesn't exist. It just means we can't talk about its slope. All right. You guys did a great job today. We're going to be working on writing equations of lines in our next lesson. But for right now, let's use the remainder of our time here to be working on homework. And I know that this class will utilize it because you guys are doing a great job with homework this year. Today is the 24th, so this will be due on our next class, the 26th. 2.1.3, 31 to 35. And I forgot to give you answers to our last homework assignment, so I'm going to do that right now. If you could please get your homework out from the one that you already showed me, I want to give you answers so that if you have questions, you can ask those during our homework time here.